Good day, everyone. Thank you for joining us for our TREP mid-year update. The session's going to be recorded, and we'll send out a link in the follow-up package, just so everybody's aware. We have a lot of material to cover, so I don't want to delay the start here. So I have one slight change to today's presentation. Matt is fine, but unfortunately has apologized for not being available to join us today. So I'm going to kick off the presentation and moderate. My name's Jeff Sewell. I'm actually the TREP product manager. We'll get into intros in a second. I just want to hit on some functionality features with our On24 platform that we're using today. On the bottom of the screen, you'll see some widgets or icons that basically let you control your user experience. And I would suggest to keep the slide widget and the media widget open. So you can see the slides, the presenters, and then Joe's demos in the second half. And then also please keep the Q&A widget open so you can ask any questions as we go through the presentation. We have actually 4 polling questions today that we'll send out during the presentation to get your feedback in real time. All responses are anonymous, and we're going to share the responses so everyone can see where you stack up with the rest of the crowd. Let's do one of the polling questions right now so people will have an idea how this works. All right, let me, oh, wrong button. Wrong button. All right, so basically, one of our deliverables for fourth quarter is we're going to provide support for Red Hat 8. Which coincides with the end of life of Red Hat 6. For Red Hat 8, we do not expect to extend support for RRMP daemon. However, we will continue to support RRMP daemon in Red Hat 7. So our question is, does this pose any upgrade challenges? In this case, it's just a binary answer. So if everyone could please make a choice here, and then we'll share the responses. I'll give you a couple seconds here. Just give everybody a chance. All right, let's see what we have here. Okay, majority of the people, the answer is not a problem. Some people, the answer is yes. So in this case, for anyone that has a problem, certainly please follow up with one of us. And so we understand what the issues are. Again, we have some time on this. This deliverable for Q4 deliverables actually scheduled for October. All right, so just ping one of us and let us know what the issues are. We'll see what we can do to address it. All right, moving along. Basically what we have is the list of members on the TREP team here. I'm not going to run through everybody, but I just want to provide you the 4 presenters that we have today. And this is in order of their presentation. So we have Mahesh Bomanaya Kanahali, who is our technical specialist, and he manages our global 2nd and 3rd level support teams for TREP. Next, we're going to have Vesna Gazdenovic, who is our TREP product manager for the value-added services that includes ATS that she's going to talk about today. Again, I'm Jeff Sewell. I'm the product manager for TREP core services. That's ADH, ADS, ADS-POP. And then our 4th presenter, and the easiest name to say other than my own today, is Joe Miller. He runs TREP development team, and he's our lead developer. Right. I'm going to quickly run through the agenda. Basically, this is wrapping up right now, the opening statement. Again, this is going to be a 90-minute presentation. Mahesh has the first 60 minutes to run through what's basically our first ever ADS-POP performance and tuning guide. Pretty extensive and detailed, a lot of information. Again, Q&As, please submit during the session. There's no use holding them till the end. Then Vesna and I will take 10 minutes to run through the large enhancements for this release at the end of next week. So that'll be 3.4.2. And then Joe will consume the last 20 minutes. He's going to run through, whoops, am I doing something here? Hold on. Yeah, hold on. Joe's going to run through what will be probably one of our most important new features for ADS-POP this year. And then again, please submit Q&As throughout the presentation. The TREP team's online here, so we can respond in real time during the presentation. In some cases, we'll save some of the questions for the end. And whatever ones we don't get answered, we'll send out in response with the follow-up details along with the recording. All right, so I'm going to turn this now over to Mahesh.
Thank you, Jeff. Hi, everyone. I'm Mahesh Bomanayakanhalli. I'm going to be talking about the ADS-POP performance and tuning section today. So initially, we will talk about the background, understand what is an ADS-POP, how did it come about, what are the functionalities that exist there, and the deployment options, connectivity, security scanning. So that's kind of covered in the background section. Then we'll talk about the 3 threading models of the ADS-POP so that you get an idea of how to leverage those things for particular deployments and what is the role of each of the major threads of the ADS-POP. And then we get started with the performance and tuning aspects, starting with system tuning. And then we look at the ADS-POP software tuning. And then how do we do the performance testing? What is our methodology? We'll touch upon that. And then whatever results we have so far on the Gen 10 platform, that's our reference platform for the update throughput. We added number of connections and conflation and the compression efficiency. So those are the 4 sets of results that are available as of now. And we will have a follow-up document towards the end of next week when a performance results guide will be released. So a bit of a background, if you look at a typical TREP, so we have our publisher and subscriber, and in the middle, we have the ADH and ADS simplified version. So we have an RRMP backbone, which is built on top of UDP. So into the layers of the ADH and the ADS. So on the ADH, we have at the very top a layer that uses the SSL API or the ETA or the reactor to make connections upstream. And then we have a producer layer and the consumer layer. The producer layer keeps track of what is being cached and the upstream view of things. And the consumer will be keeping track of the view of the RRMP to see how many ADSs are watching a particular item, etc. And sandwiched between them is the Mqs layer, which provides various levels of conflation and delay. And then at the bottom, we have the RRMP6 layer. And then, this example shows RRCP daemonless. That's a library that is built in to the ADH. And that's kind of a high-level view of the stacks of layers of the ADH. And then if you look at the ADS, it's largely a flip of that. So we have, at the top, the RRCP daemonless and RRMP6 producer consumer, and then again, MQoS is sandwiched in between in case we choose to deploy MQoS functionality within the ADS. And at the very bottom, we have the SSL API, ETA, WebSockets to support applications. So the ADS-POP is basically the top half of the ADH. So there you see the SSL API, ETA, the producer, and the Mqs layer is basically, it is the common layer that is used in both the ADH and the ADS. And then we have the ADS consumer here, and then the API layer to, I'm sorry, I don't know why this moved up. So that's how the ADS-POP is stacked. So I have left out the NIP multicast. That's not really a popular deployment option that we have seen. So basically, the ADS-POP then comes down to be a TCP on both sides. So it lends itself for deployments in various environments, including the public cloud. So sorry for that. I don't know why that's still going there. So if you look at the connectivity, then for an ADS-POP, you can connect that up to an upstream data feed like an EED or an RDFD or an upstream TREP. Or have in-house publishers built on ESDK or RFA. We also use the reactor code in the ADS-POP, so we can contribute to the Refinitiv contributions channel, TRCC, or connect that up to a EAS or ERT in the cloud. And at the bottom, we have all types of subscribers, the SSL subscriber, the RFA, and then the ESDK subscriber and the WebSocket subscriber. And one other thing to add here is the technology in the Electron Edge device or the RDFD or the EAS connection point or the ERT cloud. That's all basically an ADS-POP itself. So this is well integrated in the ecosystem and well used over the years, well proven. I'm not going to go through the functionality. I just put this slide to show that all of the TREP functionality that we are used to, it's all there in the ADS-POP, except the hot standby or the source mirroring. The provider warm standby is kind of a similar functionality that is being provided in the 3.4.2 release, and Joe is going to demo that today. So as you can see, the whole host of functionality that exists in the TREP, you see that in the ADS-POP. Let me see whether this would take us closer. Yeah. OK. So if we were to look at the deployment options, the operating system supports today are Red Hat 6 and 7, and 8.x is something that we are going to provide next quarter for the roadmap. Sorry. And you can deploy it on the Oracle Linux flavors as long as the Red Hat compatible kernel is used. CentOS 7.x is qualified as well. We can deploy it on physical servers. We can do virtualization if you any version of VMware ESXi 6.x. We can do the containerization through Docker. We provide Docker files with each release, and this is also hosted on the Docker Hub. And today, the public cloud, so we have the AMIs, so it can be deployed on AWS, and the GCP and Azure support is coming down the road. Per today's roadmap, it is next, in the first half of the next year. One other question that we get asked frequently is about the security scans. So this is all shared in the README of the software package that we provide. The Veracode and the Black Duck scans are done with all major versions. And because we do the containerization, Twistlock is another security scan that we go through. So as far as I put in some references here, so the major reference point today is the ADS-POP configuration file. There's a lot of information at the bottom of that file. And we also went through a simplification standardization effort as part of the TREP 3.3. So there is not a whole lot of configuration you need to change. You just have to define your endpoints, and that's usually sufficient, and which kind of threading model you're going to deploy. The ADS installation manual covers some of the concepts, and we have plans to release an ADS-POP specific installation manual either later this year or early next year. And the demo tools is something that is a good document to reference. It gives you the various options that are there with the test server, the test client. Those are the two primary tools that are used to verify the major functionality of TREP, and it extends to the ADS-POP. And then we also have a TREP Docker manual that is provided with each release of the software. And then there is an architectural overview of the Kubernetes that is available on myrefinitiv.com. Let me see whether this works better. OK, now if we switch to the next topic, which is the different threading models. So essentially, we have 3 threading models of the ADS-POP. One where all the functionality is in a single thread that we call the main thread. So that was the first gen of the ADS-POP. And then we added writer threads to offload the distribution capability, the last mile functionality, such as the compression, the encryption, those kinds of functionalities are all in the writer threads. And we added item threads for about a year now, beginning with the version 3.3.2, so that if there is a lot of traffic from the upstream, we can do the horizontal scaling of that message handling at the top level instead of everything going through a single main thread. We also have a couple of other threads, the REST thread for REST functionality that was released about 6 months ago with 3.4.0. We have a DNS thread for name resolution. And when we have the item threads, there is an stats aggregation thread. So those are the threads, but I'm not going to talk about that because they're not involved in the data handling. So this is a very simple view of things. If you were to use just the main thread, everything happens in the main thread. And if you want to use the writer threads, then the functionality of communicating with the publisher, the caching, the Mqs, load balancing, or standby, request routing kind of functionality is all handled in the main thread. And the writer thread will do the communication with the clients, the just-in-time conflation, conversion, last-mile conversion to client application, compression. So that is all done in the writer thread. So if you have a large number of client connections and low to medium message rate, this is a good threading model to use. And then beginning with about a year ago, 332, we have a layer of the item thread at the top. So all the functionality that the main thread used to do has been now done in the item thread. The main thread is still there. It connects to the upstream, but it is used for the directory synchronization, internal housekeeping, but it is not really used for the message flow for the interactive services. But for the non-interactive services, that message flow is still through the main thread. And then we have our writer threads that have been there for about 10 years now. So that's the 3 threading models we have. And then beginning with the Linux 6.x, we have thread names. So if we do top, for example, you can see an ads.dns or an ads.wt.instance or an ads.it.instance. So it becomes easier to see which thread is taking up resources. So that's the main usage of that. And we also have configuration entries to do any thread binding through the pop.cnf. So just to see how can we deploy ADS-POP in different ways. So if we were to take a sample TREP deployment where we had 4 EEDs and the ADHs connecting to each EED and then RRMP, ADSs, and then the subscribers. So we can shift this to 2 layers of ADS-POPs. So we can replace the ADHs with the ADS-POPs at the top, and we can do the caching, we can do the Mqs, and asymmetric load balancing, warm standby, all the functionality we can do at the top. And at the bottom, we can just use the ADS-POP as the fan-out device. And we may choose not even to cache if we don't have to, because it's just a hop away. The important thing here is it's all TCP. So there is no multicast involved. So the warm standby capability is there, so that can be leveraged for providing redundancy. Okay, with all of that background, we get into the performance tuning aspects. So the system tuning is one of the important things that we do to get good performance. So we largely follow the vendor recommendation. For quite some time now, most of the vendors publish good documentation, and the default behavior of the systems in general is either geared towards high throughput or power saving mode. So the power saving is the one that we need to watch out for and detune that. So BIOS tuning, the OS tuning, and the adapter are kind of 3 areas. And then I also have put together a list of system tools that are helpful in understanding how the system is functioning and troubleshooting if there are any problems. So with the Gen 10s, the BIOS tuning has become much easier. So now there is the concept of a workload profile. So we no longer have to go and tweak every single thing like a power regulator or turbo boost or no-see state kind of a thing. So instead of doing that, we can choose an appropriate workload profile, and then all of the settings are in one place. But the default in this case happens to be the general power efficient compute, and that's not suitable for our workload. So we can use high performance compute or general throughput compute, and we have ended up using the low latency profile, but it doesn't use the turbo boost. So you can do the customization. You can use these workload profiles as a baseline, and you can customize on top of that. And then, as in the past, you can use the conrep to verify what are the settings. So that's what I included on the right-hand side. So those are some of the settings you see in the conrep. Conrep gives you pages of information in an XML format. So you can see every single setting that you have achieved by choosing a certain workload profile at the BIOS level. Now, when we talk about the next topic, which is the OS tuning, so that involves the boot options that we choose, the system services, which is essentially disabling some of them that are not needed. And the important thing is the buffer settings for the TCP buffer settings. That's the kernel changes we make. And then just like, well, actually 10 years ahead of HP, Red Hat came up with the concept of a system profile. So you can choose a profile that meets your workload. So that's also there since Red Hat 6 days. So we continue to leverage that. And then the power management policy is basically to turn off some of those power saving options. And same goes with the kernel modules. We just unload what we don't need. So, okay. So when we go to the boot options, so there are basically 2 or 3 things that we do. So the Intel idle maxi state of 0, so that prevents the kernel from overriding the BIOS state setting. If not, there is an option. If not, a driver or application can override it. And then ignore the MCE, the polling. So that's a good one to set, and no soft lockup. So otherwise, you will see lots of logging. So those are the 3 things that we are calling out here. I think the transparent huge page is also important from a performance point of view. The system services, I'm not going to go through everything. You will have to customize it based on your requirements. But I think there's a nice paper by HP about low latency. You can use that to get an idea for what are the things that you don't want. And you can go through that and selectively keep the services that you need. It's also a good security posture. And when it comes to the kernel tuning, so basically everything you do is in the syscontrol.conf. So a few things that we do are about the buffer management, and then there is the netdev max backlog. That's a good value to set to a higher value when you have high packet rates. So you can do the syscontrol -p if you want to read any of the changes, or the reboot takes care of that as well. So system profile at the OS level, so it's been there since 6.0, as I mentioned, managed by the tuned ADM command. So I think the slide was talking about the various profiles that exist, balanced, between the power and throughput. So there is a desktop profile, latency profile, network throughput, network latency, throughput performance, and a couple of ones for the virtual. So the tuned ADM list will show you what it is set to. I think the default for the 7.x is the throughput performance. That is sufficient for most of our needs. Network throughput is something that Red Hat recommends if you are doing 40 gig or if you have really old Intel chips. So the system tools, going from top to NICStat, NetStat, NUMA control, LS Topo, Conrep. So there are a whole bunch of things that are available. And iPerf is another good one whenever you're building up any new system, or if you suspect that you're not getting your expected bandwidth, you can use iPerf. So that's a good one. And things like perf you use mainly to see how much CPU is being spent on each function. That's more helpful for development. So those are some of the system tools available. And from an ADS-POP point of view, we ship ADS-Mon. That's the primary observability tool. Then there is also a REST interface now, so we can use curl to get some of those things that are in the shared memory. Because we support persistency, there's a persistent tool. And the test client and the test server are the primary tools that are used. So that is shipped now, along with sync-driven source, even though we are de-emphasizing sync-driven source and, RMDS test server, or test server, short name, it does all of that functionality. And then we also have a bunch of streaming tools to verify the WebSocket functionality. That's all packaged up with each version of the ADS. Okay, so now getting into the software tuning. So we have some of the configuration settings, including the TCP buffer settings that we do in the ADS-POP.cnf. So that's important. And the other one is the processor thread binding and the interrupt binding. So those are the things that we need. The goal of the processor thread binding, interrupt binding is to minimize the NUMA migration. So that will give you better performance. And also, especially things like open window of the subscriber has an impact on, how many images you get per second, the image throughput. So you want to make sure that the pipeline is full, the items are, ready to be requested. So yes, a couple of things like the message packing and the publisher, that's also important. If the publisher doesn't do any message packing, if it is, one update in every packet, then the performance of the receiver suffers. So there are a few things at the publisher subscriber level as well that are important as part of this tuning. So getting to the thread and interrupt binding. So the approach is we need to understand the data flow, understand the system topology. The tool to understand the system topology is LS-Topo. There's also an LS-Topo no graphics option for textual view of those results. And we can do all the threads of the ADS-POP through the configuration file. So there are entries to bind every single thing. And then there's also an option to say bind threads by default. So, you don't have to bind that REST thread or the DNS thread, and it will take care of those things, or the stats aggregation thread. And then for the interrupt binding, you can do that yourself, or the vendors like SolarFlare provides this SFC IRQ affinity. So that can be used to do the interrupt binding. And then we can use top because we have the thread naming with Linux to see where things are bound. And then at startup, things are logged to see where things are bound. And you can also use ADS-Mon. But if you make any dynamic changes, obviously ADS-Mon is not going to pick that up. So top will be the way to go. And a couple of things about what not to do, right? So on systems where you have high rate of interrupts, for example, when you're, speccing this to handle thousands of connections, we have those use cases in production. Make sure not to bind the interrupt handler along with one of the main threads of the ADS-POP, like a main thread or an item thread or a writer thread. So make sure the interrupt handler is on its own core. Oh, I'm sorry, I don't know why this keeps moving. And also don't bind a writer thread and an item thread to the same core. It will work to an extent, like 50% of what you expect, and then you'll see unexpected failures. So let me see whether I can get back to where I was. Sorry, this is moving too quickly. All right, so we touched upon that, what not to do kind of a thing when it comes to thread binding. So you can understand the system topology. So it shows you the relationship between the cores and where your NIC is with respect to the NUMA node. So a graphical view would be something like this. So I'm showing a partial output of the LS-Topo no graphics on the Gen 10 server. So you will see on the node 0, what are the cores, CPU cores that are there, and NIC is associated with which NUMA node. So that will be helpful when you do the binding. And obviously, the message flow is pretty straightforward. You can see the data comes in through the top NIC into the ADS-POP software, goes through the item thread, and then on to the writer threads based on the interest, and then to the south NIC. So those are kind of the 4 things that you have to account for in any of the binding exercise. And except for the nick binding, you will see that you can do all the binding of the rider threads and the item threads in this case. I have left out the bind thread by default that can go to one of the unused cores. So that's how you configure those things. And then if you look at the output of ADS-Mon, that will also show you where things are. And with any reasonable load, you will see how much CPU is being used by each thread of the ADS. So you can verify that through TOP. So that's how you will verify where things are. When it comes to the ADS-POP configuration, that's the other thing. You will see that the default values are listed, many of them here. So only in some cases, when you need high image retrieval, for example, you will change the minimum open window to like 1,000. If not, the default values are reasonable. So the hash table size is another one that is not typically something we set. It is set to 300,000, assuming 100,000 max cache. The rule of thumb is to set it higher 2 to 3 times more so that there is no performance penalty. And then the typical TCP receive size and the send buffer sizes, I think they will also be defaulted to 2 meg in some cases that it is not currently in 342. One of the nice functionality that has been added is the round trip latency. So it isn't so much a performance play, but it's more of an observability. So at a route level, you can see what is the round trip latency. That will help in understanding where do you want your primary connection to go from an ADS-POP if you have multiple places to go. So what else? I think most of the things about the message packing, they're all defaulting to true. We suggest you leave it the same way. And the thread binding, I showed an example before. You will have to do the thread binding as necessary. Sorry, I don't know why it keeps switching so much. So yeah, I think if you have a small number of connections, by all means, increase the buffers. So if not, the defaults of 200, 400 are probably sufficient for most of the use cases. The Sandbox Size, same thing, 64K. If you have a small number of connections, by all means, you can increase these values. If not, the size of the ADS-POP becomes too huge. So that may impact the performance as well. So something to keep in mind. I think I mentioned a couple of things about the publisher-subscriber tuning. The standard things are the send and the receive buffers. And if you want a low latency from the publisher point of view, there's TCP no delay option that you can set. Message packing has an important impact on the downstream. So enable the message packing, pack at least a few updates in every single message that goes out, and implement the process and interrupt binding, very similar to what we do for the ADS-POP. And the open window from a publisher point of view is how many requests it can receive at the same time. So that has an impact on the image retrieval. And similarly, on the subscriber, we have the TCP buffer settings, TCP no delay, and then a couple of request flags if you want an item key instead of the stream ID, or if you want to see the conflation. So those are flags that you can set, and do the same interrupt binding. Open window comes into play again for the image retrieval. So those are some of the tunables in the ADS-POP. Majority of them, you can go with the defaults. Just a few things you may have to change. From a methodology point of view, the test setups are fairly straightforward. You have an ADS-POP on one end and another one where you see the publisher and the subscriber. We use the test server to generate the traffic and the test client to make all the requests. And the POP is tuned for max throughput by default. We increase the update rate until either the CPU limit is reached or we see errors. So we want to make sure there are no errors. We want to ensure that the expected number of messages are received by the client application, whatever is sent. and the test server and the sync-driven source, it doesn't cut the channel if the ADS-POP cannot keep up. You will see messages to indicate that it is not able to push all the messages. So that's another indication that the POP is not able to handle a certain message rate. So those are the things to watch out for. And as the case may be, we will have to leverage multiple instances of the test server and the test client because we don't want the tools to be the limitation. For example, a test server can do on Gen 8, let's say 3.5 million updates per second. So if you want to stress an ADS-POP on a newer platform, we want to run at least 2 instances. So a test client, we'll have to run many instances to consume all of the data. So I have included some of the specifics that we use. So from a test server point of view, we use the sample XML that is in the demo package of the ADS and the ADH. It uses a pre-encoded 74-byte RWF level 1 message. And then we include the sequence number to align with our Electron Real-Time. And we configure 2 meg of TCP send buffer. And we set that for maximum packing when we are doing the throughput testing. If you want to do latency testing, we set that to a lower value, like say, 10 updates per message. And the frequency of writing, it's to smooth out the data bursts. So we set a value of 1,000 for this ticks per second. So that means every millisecond, the publisher flushes the data. So from a subscriber point of view, we just use the watch list, 100,000 items typically, and that file is included in the demo directory of the ADS package beginning with 340. So we don't need to go back to the infra tools to get this one file. And then you configure a reasonable receive buffer size. 2 meg seems to be sufficient. So continuing on, ADS-POP, we always enable caching, and it's by default configured in high throughput mode. Even the flash interval time writes, they're all now defaulted appropriately. So the major thing as far as the tuning of the POP goes is which threading model you are going to use, and based on that, how many writer threads or how many item threads you are going to choose, and then do the binding through the POP CNF by understanding the topology, and also make sure to bind the tools. That's an important consideration. Typically, we use a frame size of 1,500 bytes. But there were certain requests to say, hey, what if you use jumbo frames? So I have used some examples in the results section. That's probably a more reasonable deployment if we are stacking the ADS-POPs. And if we are doing the caching, the Mqs kind of a thing at the top, and we have a few ADS-POPs. So that's a layer where we can use the jumbo frames. And as far as the testing methodology, we want to make sure we run it at least for good 30 minutes. That's what we do to make sure that we can sustain like a market open or a market close. That's the thinking behind it. You can observe the rates through the test server, test client, and also through ADS-Mon. I think I have an example. So you can use the REST queries, or you can use the get file option or the -get option of the ADS-Mon to kind of get these values, on a per second basis. You can log it to a file so you can graph it later. You can do the same thing for compression, efficiency, compression ratio, a whole bunch of things. Whatever you have in the shared memory, you can do that. And one key consideration is don't enable any logging or tracing when you are pushing millions of messages per second. That's not going to work well. It's not just for ADS-POP, for the tools as well. So those are some of the things. Through the monitor, ADS-Mon is the primary monitor. But you need to be on the box. So you can monitor update rate, image rate, compression ratio, whatever is the test that you are doing. And then beginning with 340, that was released about 6 months ago, we have the REST interface. So you can do the REST queries so that you can do that remotely. So that's a nice functionality that's there now. Not sure why it's moving ahead of me. So I give an example here of the get file approach. So you can specify a file where you specify class name, instance name, variable name, and then you can run the ADS-POP minus get file option. You can repeat it every second. You can print the timestamp. You can send it to a file. So that way, you can use it for graphing. You have some data to show what the particular test looked like. Oops. I think we're probably almost there. Okay, so from a monitoring point of view, what else can you use? You can use NetStat, right? It's a TCP sender receiver. So, sorry, it's getting out of me too quickly. So you can use NetStat minus TCN. So that will give you the buffer depth. So you can see how quickly the ADS process is draining the buffers, or if it is falling behind. That's a good indication. And from a client application point of view, you can see the buffer usage to see whether there is any buffer buildup, whether there is any borrowing from the pool, etc. So that's all there through ADS-POP. You can see there, or you can also use the NetStat to see whether the send queue size is building up. So you can use that both at the application level and also at the ADS-POP level. So as a performance testing aspect, run as many instances of test client as you need. Make sure that that is not the bottleneck and doesn't put the back pressure. Okay, so performance results. So our platform is the dual processor, 8-core Gen 10 Skylake server. We used Red Hat 7.5, Solar Flare adapter 8000 series, and the network switch is the Cisco 5500 series 10 gig switch. So historically, we would just present the numbers for which threading model gave us the best numbers. But because of the various ways in which the ADS-POP can be deployed, people are interested in saying, well, I just want to run as many instances of the ADS-POP as necessary, scale those many instances in the cloud. So we want to look at the performance of various threading models. So that's why I included this test. And as you will see, we just use 2 CPU cores for this ADS-POP, 1 core for the main thread, and the other core for network interrupt handling, the DNS thread, the REST interface. So that's it. So from a compute point of view, it's just 2 cores. And, with a single main thread, you're not going to saturate 10 gig. The utilization will be under 1 gig. We just happen to have a 10 gig card and used it. So use the standard MTU, 1 millisecond flush, did a couple of routes there. So call 100,000 items from 4 client applications, non-overlapping so that there is no commonality. It's our standard 74-byte RWF message. So the upstream is RWF in this case. And so if you are using RSSL client, you can get over 1 million messages. And if the main thread is doing the conversion to market feed, then it's 640,000 updates per second. If it is doing the conversion to JSON to WebSocket, then it's 270,000. So that's one set of data that we have for the POP configured with nothing but the main thread. And if we were to do a full fan out, where we say we have a 100K watch list, we have 100 client applications, each calling the same, what do we get? So for the WebSocket, we get 670,000 messages through the main thread, and with market feed, we get 2.5 million. With RSSL RWF, we get 4 million. So that's another data point we have for the main thread. And the third one that we added is how many number of connections can an ADS-POP handle with certain assumptions of the inbound messages, right? So if we assume we have 500 items as our watch list in an ADS-POP, and you assume full commonality, assume like a bond type of deployment or conflated from upstream, and you get no more than 3 updates per second per item. So in that case, so what kind of, how many connections can we support, whether it is RWF or JSON2. I think we were requested to add market feed during the last CAF, so those things have been added. So you will see, what is the number of connections. You will see that, for example, if you take RSSL RWF, it's 500 items, 1,000 items, 5K items, 10K items. So you get an idea of, depending on your items expected message rate, the client protocol, it gives you an idea to see how many instances of an ADS-POP you may need for your deployment if it is doing nothing but the main thread. So now we come to the poll question. So Jeff, how does this work? Can you? Yeah.
So basically, you'll see, the analysis that Mahesh is doing is based on, in this case, the consumer application. So what we're trying to do is give you realistic metrics for the benchmark here that we're doing. So what we'd like to do is just get an idea from you in terms of, if you have ADS-POP configured for a large number of client connections, right? What's your watch list size look like? Is it, in this case, Mahesh gave you performance based on different watch list size, but if it turns out you're telling me you're only running, I don't know, 50,000 items per consumer app, then we need to change the metrics here. So if you can just give us a quick idea, how many open items you would expect to run for a client connection in a watch list size. So that's all. We're just looking for a little feedback to work with here. So if everybody could just respond to that, we'll have an idea, and then that'll help us validate testing going forward. All right. So it looks like, well, we have over 50% are over 10,000, right? So we probably need to change the metrics a bit and obviously increase the watch list sizes that we're going to be using. All right, that's helpful. Thank you very much. All right, Mahesh, back to you.
Yeah, thank you. That's great feedback. So for the next set of tests, then I don't need to worry too much about the 500 items and the 1,000 items. So I can instead move to 25K, 50K, 100K kind of watch list sizes. So this is another test. If you were to leverage the writer threads, what can you do? So you will see, comparing to the main thread option with the 5,000 items or the 10,000 items, you will see that's a pretty linear 5-fold increase in what an ADS-POP can handle as far as the number of connections with the same assumptions. And thank you for your feedback. I think we will add the 25K, 50K, 100K examples when we release the results document next week. So then let's look at the item threads, right? So that's all good for a distribution point of view. But if your ADS-POP has to handle high message rates, we saw that if it is just the main thread, it could do 1 million updates per second in and out. So if you were to use, 2 item threads, or 4 item threads, or 5 item threads, you see the values going up to 3.5 million. So that's all on the same NUMA node, because the configuration was, 2 writer threads, and then we varied the number of item threads to 2, 4, or 5. Everything is in the same NUMA node, 8-core single socket. So that was a good boost. And if you have to cross the NUMA boundary because you want to use even more item threads, like I think in this case I used 7 item threads and 4 writer threads for another NUMA node, you don't see the same level of improvement because of the NUMA transitions. So that's a marginal improvement, just over 4 million updates. So I would stay with the 5 item threads, 2 writer thread for such a configuration because you get much more for the amount of CPU, the compute you're spending. And this is an example where I use the jumbo frames. Obviously, we will release the reports with the standard MTU 1500 bytes as well. but there was a request to do this test with jumbo frames for the top-level feed POP. And also in all these results, we are showing how much network bandwidth we are utilizing. I think in this case, it's 10 Gbps. You don't need that much. But even if you look at the other results with the supported number of connections, we are capping it to than 20 Gbps, because that seems to be the common option, that you have a couple of 10 gig cards dual ported. So there will be results published also without any constraints, but we'll also include the numbers with certain constraints so that it is more applicable for common deployment scenarios. All right, so this is with the item threads and using the writer threads, obviously 5 writer threads at least. So if we had 800,000 inbound messages, we could do 4 million out. And if we had 300,000 messages coming in, we can do 45 connections, taking us to 13.5 million. So that's at 10 Gbps bandwidth limit with our message size. So you will see that some of these tests are run with this is with 100K watch list. I think, yeah. So this is with the 100K watch list. So you get an idea of how many connections you can handle. So this is used for probably something like a feed POP, or if you have large in-house consumers. So that will give you an idea. Sorry, I think it went over the conflation. So, okay, so one other request that came in after the last CAF was, so what is the impact of the conflation? So I did a few tests with, a 1,000 millisecond or 1 second conflation, 500 millisecond, 330. So these are some of the common deployment options we have seen, the 1,000, 500 millisecond, and 330. So I went down a bit more to the 200 millisecond. So that was also a reasonable number, but you will begin to see that there is an impact of this retrieval of these various views out of the cache. The 100 millisecond is actually really low. I think it's lower than 1 million updates per second. So that's something that we are looking into to see whether there are enhancements that can be made to improve that result. But for now, I would say 200 milliseconds and higher seems to be reasonable as a performance metric. And the last set of numbers I have are about the compression efficiency. I think we probably discussed this in the last CAF as well. So this is, I'm using this mostly to talk about the approach we take, and don't use the sample XML and run through it, because the compression algorithms, whether it is zlib or LZ4 are smart. It will figure out the pattern, and you will see astonishingly good compression ratios that you will never achieve in real life. So the way to do this is take a certain watch list and run it through live data, or capture the data through test client, binary option, and then replay through test server. We also have an option now to say to stop replay after going through this once, kind of an option. So use either of those approaches, and then if you're using zlib, the compression level 3 is what we have seen to give the best result, because there is a cost of doing compression. So we support zlib for all the connection types, whether it is RSSL, WebSockets, or SSL market feed. For RSSL, we also support LZ4. So this particular test leveraged 5,000 active items from Electron Real-Time, and we watched, ran the application to watch it throughout the day with a zlib compression level 3. So the results were showing a decent compression, about 70% with the RSSL and with the JSON, because it's ASCII, bigger message, 87% compression. So then I plotted the update rates and the compression efficiency for a length of time. So that's the approach to do the compression tests. So if I manage to do the LZ4 by next week, I will include that also in the result. If not, I think I will stick to the zlib level 3. I think that's probably all the slides ahead as far as the performance goes and the results. So back to you, Jeff. If there are questions, I'm happy to answer.
All right. Well, thank you, Mahesh. We're a little tight on time. Mahesh, if you wouldn't mind, there are some questions in the Q&A box. Some have been answered, but some are certainly we'll leave for you to address.
Sure.
I'm going to move. Thank you, though, for a great job, a comprehensive job on the report. I'm going to move ahead here. Basically, as I mentioned, Vesna and I are going to spend a quick 10 minutes just to look at deliverables for the next release, which is end of next week, right? We're always required to provide this disclaimer. Essentially, the roadmap shows what our expected deliverables will be in the coming months, which can be subject to change. At this point, I don't expect any of our deliverables that are on the roadmap now to go out to January to change. However, we may end up reordering some of the January deliverables back to October based on some active discussions going on. I'll have a better idea in the next week or two on you for that, all right? But anyway, for those of you that are familiar with our roadmap, we generally only show large enhancements on the roadmap. But every quarter, there's also a number of small enhancements and a number of bug fixes. In the summary of all the deliverables is always on our What's New document. In the What's New document for 3.4.2, the next release will be available end of next week. So that'll be available on My Refinitiv, all right? So Vesna's going to give you an update on ATS. That's one of the large enhancements for this quarter. And then there's 3 more large enhancements that I will talk about quickly. And then Joe is going to do a couple of demos for us, and including a demo on an enhancement for this quarter, which is the ADS-POP Provider Warm Standby. That's the one deliverable that I said may be the most important deliverable of the year. So over to you, Vesna, on the ATS.
Hello, everyone. I'm Vesna, the product manager for TREP value add products, including ATS. And on July 7th, we released a new version of ATS 1.6, which included a new ATS UI that's moved off of Flash and onto Angular to mitigate any security risks that clients have encountered. We highly encourage clients to update their old UI to the new UI due to Flash's end of life by December 31st, 2020. Included in this new UI, aside from getting off of Flash, we also have some new enhancements, which we've highlighted in the What's New guide, and also all the steps and the requirements, prerequisites that clients need are in the installation configuration guide for ATS 1.6. And we also created a new documentation migration guide for clients to follow, which shows the differences between the old UI and the new UI. And all of this is available on My Refinitiv as a package to be downloaded by all clients. We've also sent out a PCN on July 7th. I highly encourage anyone who's not signed up for product change notifications on My Refinitiv to do so for ATS, including TREP as well. In this statement, we did include what clients need to follow and any prerequisites that we encourage clients to have before moving on to the new ATS UI.
All right, very good. So again,
oh, sorry.
That's it, right?
Sorry, I forgot to mention, and again, if there are any questions, please don't hesitate to ask in this during this meeting, or message myself for any questions that you guys might have. We're also looking into having a possible demo for any clients that might need some help or just want to see what moving from the old UI to the new UI entails.
All right, very good. Thank you, Vesna. Sorry?
No, go ahead, Jeff, sorry.
Just to be clear to everyone, Adobe actually announced end of life for Flash back in 2017. So I don't think this is going to be a surprise to anyone. and most of the browsers, major browser suppliers, will no longer support Flash after the end of this year anyway. So this is just, it's basically a required migration that you need to be aware of, all right? So next up here on the roadmap, again, this is only for the July deliverables, is all we're going to talk about today, is the performance and tuning guide that Mahesh just went through. You can see that there's, obviously Mahesh has done some extensive testing. He's showing you how to set up and configure item threads and writer threads to get the most performance out of the server. The multi-threading itself for the ADS and ADS-POP was introduced last year. And so we build upon the enhancements to continue making the product, more useful to customers. And again, most of these requests are coming from customers. So if you have requests for enhancements, please let us know. Just as our question just popped up, that obviously people are looking at larger watch lists. So Mahesh will try to squeeze in some more testing over the next week. And then his document, the guide itself, will be available to download by the end of next week. Okay, that's part of the 3.4.2 deliverables, right? Next one, go through here quickly. We're adding map entry level entitlements as our third large enhancement this quarter, which basically will enable ADS-POP to optionally perform end user permission checks against DACs for any map entry level data. And this basically what it'll do is allows the ADS-POP to manage end user access with more granularity, which will help you obviously reduce exchange fees where necessary. All right. And then the last ADS-POP provider warm standby enhancement is due this quarter. Basically, this is a really interesting enhancement. Basically, what we're doing is the cascaded ADS-POP will be able to make 2 or more separate connections to upstream standby ADS servers and request to all open items on those standby servers. That's in addition to obviously the open items already being active on the active server, right? But obviously what this does is this enhancement will increase the resiliency across multiple standby servers and the persistence of the cache across multiple standby servers. And basically what it does simply is it'll significantly reduce the recovery time in event of a failover, right? And this feature of the warm standby complements our load balancing feature that we just released in April. So Joe is going to do a couple of demos here, including a demo on the warm standby. So just before we get to that, though, I just want to do one more polling question here. Basically, this question may look familiar. What we have seen, we asked this question in April. That was 1 month into the pandemic, all right? We are now 4 months into the pandemic. And what we're trying to understand is, have your responses changed to these questions, right? And I'm expecting to see that the new vote will validate more of what we're seeing in the marketplace from our customers now. So if you could just respond to these, again, it's all anonymous, and then we'll post the results. All right, let's see what we have. I'm surprised, not a lot different. We have a few more people now who have already moved to containerization and orchestration. The rest of the list actually looks quite the same. All right, interesting though. Thank you for your responses there. Let's move on. Joe, we're going to turn this over to you now, and you can go ahead and run a demo. Or two.
Okay, thanks, Jeff.
Yep, no problem.
I'm not sure where we are with the slides on this thing, so I'll just screen share and then bring up the slides. Can everyone see my screen?
Not yet.
Still nothing?
Are you presenting the slide, Joe?
Yeah.
ADS-POP warm standby?
Yep.
I see it.
Okay, good. So ADS-POP warm standby for TREP 342. Those of you familiar with RFA know that we have this feature kind of built into RFA today. In ADS 3.1, we built it on the consumer side to support those RFA customers. That feature wasn't brought forward in the current version of ESDK, although I know Brian's taking a look at that eventually. But what we want to do is be able to do that feature from the provider side of the ADS-POP, or what Mahesh called the producer side of the ADS-POP. So you can use an existing upstream ADS that has the warm standby feature in it, I think, like I said, around 3.1. And then you can go ahead and enable on the provider side the warm standby. And I'll show you some pictures in a demo here to kind of make more sense. But you can have, there's one active, and then you can have actually n number of standbys. So like hot standby, you can have a single standby. With this, you can have n number. The updates only flow on the active channel, so it doesn't use any bandwidth. The refreshes, we just send empty refresh message headers. And then on the standby to active, when we detect some type of disconnect or service level outage, we'll internally in ADS-POP, we'll switch to the healthiest standby server, and then recovery is then at a conflated update level. Should, while it was in standby, the item received unsolicited refresh, or for currently presently level 2, you will get a new full unsolicited on failover. But for level 1 market price today, fieldless value pairs, you're going to get a conflated update. ADS-POP, similar to hot standby, maintains state, group, and permission data differences. That allows us to keep track, and when the standby takes over, he knows what items are out of sync with the active. He knows what group diffs are out of sync. He knows what permission lock or DAX locks are out of sync. So then instead of pulling the full image, he can just replay a new status to get everything in sync, pull the conflated update, and away you go. So configuration is pretty basic. You have an enable provider warm standby feature. Eventually, again, we call it provider warm standby because eventually, hopefully, we can get this built into ESDK. But obviously, today you'll have to. This feature will only work from cascading off an ADS. Warm standby routes I'll get into a little bit later, but it gives you the ability, kind of like you can have the ability today. You can have multiple active standby pairs for hot standby, which ultimately becomes sort of load balanced across the ADS. You can do that inside the ADS-POP. So you can have multiple groupings of warm standby servers that we load balance against. And because we load balance against them, things like ALB, hash-based routing, server regular permission routing, all that stuff works. I think Mahesh showed you real quickly the Mqs layer. So the Mqs layer sits below the warm standby layer. So you guys can, behind Mqs, you can enable it locally in your ADS-POP, but behind Mqs, and you can build up your warm standby right behind it. This picture's a little muddled. I kind of grabbed it from our current QA Confluence documentation. This kind of gives you an overview real quick of what we're testing currently in QA. You can see here's your ADS-POP layer, a single active, multiple standbys. And then obviously if you have an RFA consumer, you can take advantage of that across your ADS-POPs on the south side. And then on the north side, again, you can separate. And it doesn't have to be the same backbone, just like hot standby. You can completely different sites. It can be on-prem versus cloud. I'll show you some more pictures of that. Obviously, like hot standby, if you connect to 2 different ADSs, those ADSs are going to remap groups differently, most likely. So the active standbys in the ADS-POP will maintain those group differences and sync up the groups on failover. But again, we're trying to do everything we can to avoid that full sync-led recovery, right? And here's just another picture I've got for you. So again, just another picture to kind of show what this looks like, you know. Again, if you want to go 4 sites, 5 sites, kind of up to you how you bust that up. Obviously, now we have warm standby. We have item threads on the provider side. We now have encryption as of, I think, 3.3.3, both consumer side and server side now. And then obviously we have compression zlib, and now we also support LZ4. So you have n number of standby servers, conflated update recovery. Like I said, you can break this apart so you can have multiple groupings of warm standby servers, so you can use all your load-based, hash-based, and regular expression-based routing. Right now, I don't have an automated way of failover. Maybe I'll get some feedback from you guys when you start playing with it. But right now, I provide you shared memory interfaces. So say during the weekend through the REST interface, you guys can go ahead and trigger failover to the healthiest server, or you can trigger failover to a specific route. So then you guys can script around that and kind of do it, you know, whatever hours you want. I suppose it's not the end of the world to do failovers during the middle of the day, right? You're just playing back conflated updates in theory. It's not going to be a full sync LED, so that's a possibility as well. If you're running into an issue, you can just flip it at night, a quick conflated update recovery, and away you go. And like I said, you can do resiliency across any site, any location, as long as the upstream provider supports warm standby. Really doesn't matter where it's at. It's warm standby, so there's no content-based checks, right? We're not doing any sequence number checks. We're not doing any payload checks. It's just conflated update and go. So leading into this, we thought the ALB kind of ties perfectly into this. ALB, we added in the ADS-POP in 341, and allows you the ability to give cost groups to certain servers. So you can go ahead and you can prioritize requests towards a grouping, a load balance server versus another. So you guys can have to do something like this, right? You can create these virtual server groups. So you can go ahead and you can make this an active standby pair, make this an active standby pair. Using the warm standby routes configuration, you can show up as multiple servers and then use your ALB. So you can direct all your requests to your lower cost group first, and then only when that fills up at 95%, and then you can fail over to the other cost group. So I just had some demos, and then you guys feel free to ask questions as I go along, and I can show you different stuff as we have time. But this is kind of my little mini setup I have on my development machine. Upstream, it is in the ADS LAN, ADS-POP, but you do have to enable it. So you have to set support warm standby true. A full image cache is not required. We have what I call an on-demand cache we use for traffic management and warm standby. So it only kicks on when we have to enter into conflation, and then kicks off when we exit out of conflation. So you don't need the full image cache. Same way with downstream, you don't need the full image cache. This can be all cache off, and then you're just pulling the conflated updates from the upstream ADS. So my demo, I have a couple of RMDS test servers, as I showed. I have a couple of upstream ADS-POPs with a service running. I have my downstream ADS-POP, just to kind of show you guys configuration real quick. This is sort of the out-of-the-box ADS-POP CNF file that we ship with 342. I have a route list. I have 4 routes. And I set up my ports. For those that you don't know, have never seen this before, you can wildcard routes. So it would make the way I have my configuration now, it'd be really easy for me just to add a 5th and 6th route if I wanted to. You just override whatever port you want. You comment out your service list so it accepts all services. With auto-generate IDs on, away you go. And same with an enable provider, you can scope this per service, but what I did is I went ahead and I enabled it globally. So any service that comes up on those routes was automatically going to get into warm standby. Other features we have, I have this warm standby failure notification. It's off by default. So when you fail over, all you're going to see is completed updates and away you go. You won't see any statuses. You can turn this on and it'll send a group info status on failover just to give the indication down to the consumer application that he saw the failover. But typically kind of up to you guys if you want to get notification down to the consumer or not. The consumer will tell from conflated account and conflated update in the update message header for RSL if they requested conflation information. And then obviously we have situations right where the item can get open on the active, but we have issues opening up the item on the standby. So you guys can enable on the fly or statically via config some additional logging so you guys can track items that we can't open up on the standby. Let me bring this up quick. I have 4 routes. I have them all going to a single primary server. So if you look here, I have a single primary server. And then if you look in my warm standby stats, here you can see the 4 routes that are above that primary server. So I have a single active and then I have 3 standbys. I'm just going to open up 3,000 items. And you can see all 3,000 are open across all connections. But only updates from the active are going to be accepted. So I'm going to send 1,000 to each server, and I'm only getting 1,000 as my client. Now, if you guys go into the primary server stats, you can tab up to the warm standby statistics, and this will tell you all the servers that are feeding that primary server, along with these options that you guys can set through shared memory. Here's your port administrator failovers, and here's all your servers that are feeding into this guy, and different parameters that you guys can control as far as failover rates and retry times and paces. So if I go up to one of my ADSs, and I'm going to go ahead and I'm going to run a script that closes the listening port and then disconnects the two connections that are on there. So I did failover, and all you can see is I replayed 3,000 updates conflated, and then I got completion counts and times. No statuses, nothing. Go back to your warm standby stats. You can see 2 of them down, and then I flipped over to active. If I bring it back up, your downstream ADS-POP is going to reconnect, but obviously it won't switch to active. Those 2 new connections now will go back to standby. And then because they're standby, you don't see anything. It just reopens the 3,000 items. If you guys want, there's statistics on the upstream ADS. You guys can go into your sync mount stats. You can actually see the number of updates that are being delayed, merged. So these are the updates that are getting conflated. You can see my up on update rate from here. 0 because both my sections are in standby. So pretty cool. So I know my actives on my other ADS now. So again, I can go run that same script. And then you guys should see from the server ID, you see this active go down, and then it's going to switch to one of these 10,004, 10,001. There you go, switch 10,001, and then I received 2,000 played updates plus resume my update stream once it was done replaying. I'll bring the guy back up. And then real quick, I'll show you how this can kind of work in conjunction with ALB. If I go back to my configuration, and I'm going to assign a cost to each group. So routes 3 and 4, I'm going to assign a higher cost. Now I'm going to use my route configuration parameter. I'm now going to group these routes into 2 different primary servers. The 1 and 3 are going to be an active standby that feeds one primary server, and then 2.4 is going to be another route that feeds the other primary server. Now for my stats. And see others connect. I'll see 2 primary servers, and then because I have LB turned on, all the requests go to my lower cost group, whereas before it would balance if I turned off ALB. Behind the scenes, I have 1 primary servers. Okay. So that'll work so you guys can go ahead and create warm standby pair to, say, like your cloud backup site. And then for your local site, then you can go ahead and still do warm standby, but then you can make it a lower cost group. Whereas if you go back and kind of show you if you create, turn off the server costs. Go back, and now what it does is because they're all the same cost, both primary servers are going to get load balancing cost. Now you can see I have 2 actives and then 2 standbys. I go to my primary server stats, and you'll be able to see what servers are supplying that primary server. And then I mentioned as far as maintaining states, so the warm standby states will have your diff states, and then there's a new column inside here where you can actually see where all the counts are for your standby. The retry counts, open failure counts, are all your state diff counts. So from RMDS test server, say for example, I want to mark everything failed from that one RMDS test server. You'll see now that I'll have on your standby, you'll have items going to your sync state, and they went down to active fail. Any questions? See if there's anything here. Otherwise, that's kind of all I had. Feel free to reach out to me. Any questions you have, enhancements that you'd like to see along with this. And for sake of time, I had one more slide real quick. I think Jeff mentioned it. Something else we're delivering for 342 is the map entry level entitlements. So it's a feature that you enable on top of DAX. So you can enable DAX, but then you can additionally enable and control this feature on or off. TREP already caches the permission expressions in the map entries today. So it's all there. It all flows through TREP. Just a matter of enabling this feature. And then we use the same DAX user profile checking that we use for update level and item level checks. So again, the benefit allows you to publish a single map, say an order book, and then you can permission content per user. So thanks, Jeff. That's all I had. I can kind of go through maybe some of these questions. Anybody's had any questions that they'd like to see?
Yeah, thank you, Joe. That was definitely very good. The demos are always useful. Obviously validates that what we say we deliver is actually up and running and working, so thank you. Basically, there are a couple questions for you there on the panel, if you can hit those.
Sure.
What I want to do next here then, let me just go on. We have what looks like to be our last polling question, right? We've been running ADS-POP in Amazon Cloud since fourth quarter 2018. Basically, the cloud doesn't support multicast traffic, so we can't do actually hot standby. We can't implement hot standby in the cloud without multicast. So basically, warm standby is the best we can deliver as of today, and it's certainly a significant enhancement over cold standby in terms of time to recovery. So this question here, basically what we're asking for is, how much of an issue is it for you that the ADS-POP only has a warm standby capability and not full hot standby capability? And again, it depends on your use case, but obviously if you're moving to the cloud, if you're planning on moving to the cloud, obviously multicast traffic prohibits us from running hot standby right now. So this is the last polling question. Give everyone a second there. And okay, let's just see where we're at here. Okay. All right, interesting then. Yeah. All right. Interesting there. Obviously not a deal breaker for anyone. That's encouraging. At least you understand the use case. For many of you that are not in the public cloud anyway, obviously the choice number 3 to be able to leverage, still leverage ADH for hot standby certainly makes sense. All right, thank you for your responses there. We got Q&A. We have a couple minutes left, although it appears a lot of questions have been answered. Joe, do you see any there you want to call out and repeat that you think would be useful for the whole audience? We will send out the questions and responses on the follow-up email that will go out. But in the meantime, Joe, do you see anything there based on your presentation that you think is worth sharing with the audience?
Yeah, sure. I know Larry asked about the wildcard routing, the wildcarding for the routes. So it kind of looks like this, Larry. You can just go ahead and you can remove the route name in front of it. And then you go ahead and just do a dot route. So every route will pick up that same port. In this case, I don't want to do that one, but I can override whatever I want as usual. Then for the other parameters, you can just go ahead and wildcard. And then it'd be very simple, just add more routes as you go. And then you only have to override specific things that you want on that route. So we use that all the time. So that works out good. And then Sean, yes, you can get client notifications. So I have an optional parameter to go ahead and send a group info event. So when we fail over from active to standby, it'll send group status info events, which of course won't change the data state. It's just notification to kind of get down to the consumer that failover occurred. Otherwise, if you're an RSL client, you can always request conflation information on updates. So when we pull those conflated update messages, then you'll go ahead and you'll see conflation counts and conflation time on those updates. And then I think Simon had a question about map entry level entitlements. So Simon, today, you know, obviously you have locks, you have DAX locks, permission expressions at the item refresh message image level, right? You can optionally supply them on updates as well today. So like if there's a lock on an update, we still do the DAX permission check on that. If the user's not permissioned for that DAX lock, then we discard the update. So this takes it down into the payload. For maps, maps can contain permission data as well. And then each map entry contains a lock. So what this feature will do when you enable it is we'll have to go ahead, we'll crack open the container, we'll decode the map, and every map entry we're going to do a DAX check on every map entry to see if that user is permissioned for that map entry. If that user is not permissioned for the map entry, then we go ahead and we filter the map entry out, and then we go ahead and we'll send them whatever map entries that user is permissioned for. There's going to be obviously some resource hit to that. Every fan out will have to decode and go through the map and then re-encode based on what the user can see. But that's kind of the cost of doing business. It definitely helps versus providing service level locks and republishing, say, your order books multiple times based on that service. Now you can do a single service, a single order book stream, and then permission based on a per user basis. So I hope that helps. We don't provide, for our maps from Electron today, we don't provide any permissioning. So this is really going to be probably for your in-house map providers. I think, Sean, I mentioned about the client notification. And then as far as failover, the idea, worst case, if there was some issue where we weren't able to open the item on the standby, or while this item was on the standby in the upstream ADS, he received a new full refresh. We'd obviously have to play back refreshes when we failed over, but the goal is that everything fails over with just completed updates for level 1. So what happens is the upstream ADS, we send notification on the login of the source directory, whether the service or the connection is in active or standby mode. The upstream ADS, if it sees it's in the standby, that's when it's going ahead and kick in, and everything that gets from that point forward is going to conflate. And then when we send notification to go from standby to active, that's when the upstream ADS is going to start playing back completed updates. But worst case, right, if there's an issue with the standby not being able to open the item, or the standby did receive a full vsync or a full trash cache and a full image while it was in standby, then we will replay with a new image. But those should be rare. Most of the times, we're hoping for a complete update recovery.
All right. Thank you, Joe. We're basically about out of time. So thank you for the presenting and the follow-up on the questions. At this point, everyone, I just want to say in closing, we do have 5 more large enhancements on the roadmap between now and January. So the next deliverable after the next quarterly deliverable will be October, and then the next one right after the holidays will be in January. Again, what I mentioned earlier, we may be changing the deliverables of a couple of, at least one deliverable from January back to October, and possibly one from October into January. So we'll make a decision on that in the next week or 2 at the most. And then I will update the roadmap to reflect that on, which will be on my Refinitiv. I'm happy to send out a link to anyone if you want to get the update, if you haven't been using my Refinitiv, but you'll have to drop me an email, because this program, the platform we're using today, the invites are sent out through marketing and GDPR. does not allow marketing to share email addresses with me. So when we send out the follow-up notes, obviously the beginning or whatever second or third slide has all our contact information. So if you want to send an email directly to me, I will follow up with you and let you know if there's changes to the roadmap. All right. And then the last thing I want to say, obviously, thank you everyone for attending today. We had a good turnout. Obviously, some great questions, a lot of questions that you'll end up getting a response for in our email. And there's a survey, 3-question surveys, I believe is what I saw here at the end. One of the questions, if you don't mind filling out the survey, is asking you what other TREP or DAX topics would you like to hear about? And I don't know if you noticed the TREP team, but I added Ted Lukowski to the list, who is also, he's the DAX development manager and the DAX architect. I'm going to have him involved now. So going forward, like I say, we want to expand this to any issues on TREP or DAX. So please fill out the survey at the end and give us some feedback. Again, we appreciate your time. We know it's a long session here, and we hope everyone stays well and stays safe. Have a great day. Appreciate your time and look forward to the next time we're together. Have a good day. Good evening. Thanks.
Thank you, Jeff.